recently built a DIY Stream Deck. In this video, I'm going to go over what a Stream Deck is, how my DIY Stream Deck works, and the cost comparison between the real Stream Deck and my DIY version. In a few weeks, I'll upload another video about how to set up one of these devices on your own. A Stream Deck is a device from Elgato, a sub-company of Corsair. It's a macro keypad that connects to your computer, and pressing any of the buttons on it can trigger events, like switching scenes when you're recording a streaming, or controlling IoT devices, or even sending automated tweets. You can also chain multiple of these events together in their software. It is intended for streamers, as the name suggests, but just about anyone can speed up their workflow with one, as it's like having a second keyboard of just keyboard shortcuts. It comes in 3 versions, a 6-key version, a 15-key version, and a 32-key version. I would really like one, but one of the shortcomings of it is its price. $200 for 15 buttons is just too much in my opinion. And I really wanted a cheaper option that me and other non-professionals could use, even if it did not have all the features of the real Stream Deck. This is my DIY Stream Deck. It's powered by an Arduino and makes this 3x4 membrane keypad into a fully customizable 12-key macro keypad. Pressing any button sends data to the computer, which can be understood by a program running on the computer. You can also connect multiple keypads to the same Arduino, or connect multiple Arduinos to the same computer without causing any problems. And it can be made for only $20 for a 12-key version. I've used an Arduino Uno, which costs $23, but a $12 Arduino Nano will work just fine. The membrane keypad can be bought for around $4, and the other miscellaneous items like jumper cables and a 3D printed enclosure can be bought or made for $4. I could not 3D print an enclosure, as all the libraries and other places with 3D printers are closed right now due to the COVID pandemic. When a button on the keypad is pressed, it will send a character to the computer. Each key has a unique character to identify it, via the serial console, which is actually a virtual serial port. This can be recognized by a program running on the computer, which can then trigger events on the computer. This is the code that runs on the Arduino. The keypad is first initialized using the keypad library, and then the serial monitor is set up. The Arduino will then listen to button presses on the keypad. If a button is pressed, then it will send it to the serial monitor, which is actually a virtual serial port used for communicating with the computer. Here's the program that runs on the computer. First, it initializes a serial connection with the Arduino. In my case, the Arduino is connected to the virtual port COM5, but it might depend based on how you've connected your Arduino and set up your computer. I'll go into more details on how to find out which port your Arduino is connected to in the next video. Then the program goes on initializing other things like an OBS, WebSocket connection, and a virtual keyboard. The program then goes into an infinite loop and tries to get data from the Arduino. If data is received, it goes into a long if statement about what to do based on which character was sent. I don't think there's any better way to do this, as Python does not support case statements, but let me know in the comments if you know a better way. You can change these lines to make the program do whatever you want. You can communicate with OBS Studio, or recording software, to the OBS WebSocket, send text like you typed it instantly with the PyInput library, control IoT devices with IFTTT, open applications, send tweets with the Twitter API, pretty much anything Python can do, and Python can do a lot. I have connected one keypad, but you can connect many to the same Arduino. The Arduino Uno has 20 pins and the Arduino Nano has 21 pins. The number of pins required by each keypad is the number of rows plus the number of columns. So an Arduino Uno can have 2 3x4 and 1 3x3 keypad connected to it, for a total of 33 keys, while an Arduino Nano can have 3 3x4 keypads connected to it, for a total of 36 keys. A single computer can have unlimited DIY Stream Decks connected to it. I will go into the details of how to set all of this up in the next video. An Elgato Stream Deck costs $200 for the 15-key original version, $140 for the 6-key mini version, and $360 for the 32-key XL version. The cost per key for these are $13, $23, and $11.25 respectively. My DIY Stream Deck costs $12 for the Arduino, $4 for each keypad, and $4 per keypad for jumper wires and added 3D printing cost. This makes for a cost per key of around $1.70 if one keypad is connected, and $1.20 if two keypads are connected, and $1 if three keypads are connected for 36 keys. Keep in mind that I'm calculating this with only 3x4 keypads, but there are other variations also available. Should you get a Stream Deck or should you make a DIY version? If you stream professionally or are involved in a similar job, you should get a real Stream Deck, as it has some features that my device doesn't, like screens on each key, which give you visual feedback and also allow for folders. But if you're just a student or a non-professional, you would be well off with the DIY version. But remember, whether you're a streamer or not, such a device can really help improve your workflow. I will post the next video with details about how to set up such a device on your own in the next few weeks. Leave a like if you enjoyed the video. Subscribe for more content like this. Thanks for watching.